Alright, getting into section 1.4, looking at linear functions and slope. Hopefully a lot of this will be familiar to you from algebra and algebra 1. But we're going to be calculating the slope of a line. We're going to be writing the point slope form of an equation, writing and graphing in slope intercept, and then looking at horizontal and vertical lines and what those graphs are and what their slopes are. So when we talk about slope, slope is really the measure of the steepness of a line. It's a ratio, first and foremost. That's kind of the important part. Just remember it's a ratio that's comparing vertical change to horizontal change. So if we look here, given 2 points, x1, y1, and x2, y2, the slope of the line between those points, we use this lowercase m to represent slope. And we can look at slope as being vertical change, which is the change in y, that's right here, compared to the horizontal change, which is the change in x. The vertical axis is y, the horizontal axis is x. So the formula for finding the slope between 2 points is y2 minus y1 divided by x2 minus x1. And remember, it doesn't really matter which one you call point 1 and which one is point 2, as long as you do the y's and the x's in the same order. So just kind of looking at some general ideas of slope and some general graphs. If the slope is greater than 0, then the line will be going up to the right, and we would say that that line rises. Okay. If the slope is less than 0, we would say that the line falls. It is going down to the right. Okay. When the slope is equal to 0, that's when we have a horizontal line. And when the slope is undefined, that's when we have a vertical line. Okay, so vertical line, slope is undefined. Horizontal line, the slope is 0. Okay, so we want to avoid talking about slope and saying that there's none. It's either 0 or it's undefined, because it's two different looking graphs depending on which one we have. So find the slope of the line containing the points -3, -1, and -2, 4. So all we're going to do is we're going to look at the change in y, so 4 minus -1, compared to the change in x, -2 minus -3. And when we simplify, we're going to get 5, and that becomes a +3, so that's 1. So the slope of the line between those 2 points would be 5. Okay, that would be the rate of change of the y's compared to the x's. So if we think about a line with having slope m and containing the point x1, y1, then we want to let xy be just any other point on that line. Okay? So if we think about what our slope formula would look like, it would look something like y minus y1 compared to x minus x1. Okay? Looking at the difference in the y values between the first point and the second point, and then the difference in the x's as well. Okay? Well, if we were to get rid of this fraction here, if we were to multiply both sides by this x minus x1, we'd have m times x minus x1 equals y minus y1. Okay? So that's just coming from the multiplication property, multiplying both sides by the x minus x1. And if we just turn this around and write it as y minus y1 equals m times x minus x1, okay, then this form here is what we call point slope. Okay? And as would be suggested by the name, in order to write this equation, all I need is one point, which is the x1, y1, okay, and the slope of the line. And if I have both of those things, then I can write the equation of the line. I don't necessarily need 2 points. I need the slope and 1 point on the line, and I can write the equation of the line. Okay. So, write the point slope form of a line with a slope 4 and passing through the point -1, 3. So our general form for point slope is y minus y1 equals m times x minus x1. So y1 is going to be 3, so y minus 3. M is the slope, that's 4. and this would be x minus x1, which is -1. So all we need to do is clean that up a little bit, and I have 4 times x plus 1, and that would be sufficient. That is the point slope form of the line with a slope of 4 and passing through the point -1, +3. So what about this example? Write the point slope form of the equation of the line passing through 4, -3, and -2, 6. Okay? So in order to write the equation of a line, what is the one thing we always have to have? We always have to have the slope. So if it's not given, we're going to have to find it. So we're going to need to calculate the slope. So if we calculate that slope, we've got 9 over -6, which is going to be -3/2. Right? So now we've got the slope, and we need a point. And it doesn't matter which point we choose. We could pick any point we want. I'm just going to pick the first one. So I'd have y minus -3 equals -3/2 times x minus 4. And then all I need to do is clean up the signs. Y plus 3 equals -3/2 times x minus 4. Okay? And there is the point slope form of the equation that's passing through those two particular points. Okay, so moving on. The other form, the next form we have, which is one you're probably more familiar with, is slope-intercept form. This y equals mx plus b, okay, where we have the m, the coefficient on x, gives us our slope, and the b is our y-intercept. And you remember the intercept is where the graph is going to cross the y-axis. Okay? So for the next example, let's go back to the equation that we had in example number 3, which was y plus 3 equals -3/2 times x minus 4. And let's convert that to slope-intercept. Okay? So notice slope-intercept is nothing more than solving for y, getting y by itself. So if we start here, we distribute. So I'd have -3/2 x plus 3/2 times 4 would be 6. And then I just need to subtract the 3. So -3/2 x, 6 minus 3 would leave me with 3. And there is the slope-intercept form. Okay. If I've got a linear function, it doesn't really change anything. I'm just writing f of x instead of y, but it's still mx plus b. So when I want to graph a linear function or a linear equation, the first thing I do is I say, okay, what's the slope and what is the y-intercept? So here my slope is -3/2. My y-intercept is 2, and I can use those two things to make the graph. The y-intercept is a point on the graph, so I plot that point, and that's kind of like where I begin. B is the beginning. And the slope m is like a map. It tells you how to get to the next point. -3/2. Remember that slope is change in y over change in x. So -3/2 means I'm going to drop down 3 units. 1, 2, 3, down to -1, and then I'll go to the right 2 units, and that will be the next point on the graph. And then I could draw my line through those 2 points. Okay? Pretty straightforward. So always start with your y-intercept, that's your beginning point, and your slope, your m, is your map. It tells you the path to take to get to the next point. And once you've got the 2 points, you can draw the line. Okay. So see if you can graph this one. Pause the video, take a second, see if you can graph it, and then compare it to what I have on here. Okay. So our y-intercept is at +1. Our slope is 3/5, so I'm going to go up 1, 2, 3, and right 5. So here's my next point, clear out here, and then I just draw my line through those 2 points. And the last thing is horizontal and vertical lines. Okay, a horizontal line in the form of y equals b, y equals some number. That value is the y-intercept, and every point on that line will have the same y value. So if you have y equals a number, you have a horizontal line through that particular value. So if I had the equation of y equals 2, then I would have a horizontal line going through the value of y equals 2. If I have x equals a number, then I have a vertical line through that value on the x-axis. So if I have x equals -1, then I'm going to have a graph going through -1 on the x-axis. It's pretty straightforward. Horizontal lines are going through a y value, through the y-axis. Vertical lines are x equals because they go through the x-axis. So whatever variable you have, that's the axis you're passing through. A normal equation has x and y, and it passes through both of them. So whatever variable you have, that's the axis you're passing through, and the number that it's equal to is where it goes through that axis. Okay? So we'll do some more slope and graphing in class tomorrow. We'll see you then.